Product of powers. So if I have the same base in multiplication, do you remember what I do with my exponents, guys? Add. Okay. So it's 3 to the 9th. Base stays the same. Next one. Power to a power. What do I do?
Multiply.
So this would be 3 to the 20th. If I have same base in division, so a quotient, what do? Subtract. So this is 3 to the 6th. Power to a power, again, what do? Multiply. So multiply 3 times 4 and 3 times 3. This will become 2 to the 12th over 3 to the 9th. If it says to evaluate ever, like simplify just means keep the base and the exponent, but if it says to evaluate, go ahead and find what the numbers actually are. So this was multiply. Anything to the 0 power is 1. Okay, but make sure you pay attention to what is actually raised to the 0 power. This is just 18 to the 0 power, but if there was like something like this, 5x to the 0, that would be 5 times 1, which is 5. Okay. And last one, negative exponents, what do?
It's the root.
You can send it to the other side. Okay. So this would be 1 over 4 to the 3rd. We don't like negative exponents, they're salty. So if you recall, the number, this is A is what we call it. I don't know why we call it A. This is your y-intercept, that first number. It's your starting value. And remember, this is what we call our common ratio, what we're multiplying by. As x increases, we multiply by 1/2. We're going to make a table. You could also use your graphing calculator to get a table, just like we would for quadratics. You type it in for y equals, and then you look at your table from there. If you want to do that, that's fine. Let's practice remembering how to make a table, because this actually might be quickest to do by hand. Okay, my y-intercept is 0, 5. I want a few negative numbers and a few positive numbers, because it would go both ways. About -2, -1, 1, and 2. That's enough. As x increases, it multiplies by 1/2. So 1 would go with what for the y value? 2.5. It's dividing by 2 or multiplying by half. Okay, cut that in half again. For 2, we get 1.25. Now go backwards the other way. Now we're multiplying by 2. So 10 and 20. If you want to check it with your table and your graphing calculator, that's cool with me. And then we plot these points and make our graph. .25. So remember exponential functions, it'll keep having it, but 0 is never half of anything, and so it's never going to actually touch 0, okay? Okay. All real numbers. Remember we discussed yesterday, you could also write that in interval notation, like this, or in, what's that called? Inequality notation. And then the range. Stevie, what's my range?
5 is less than or equal to y and less than infinity.
Hold on a second. It goes below 5, right? Didn't it go below 5?
Yeah.
Oh, wait.
So where do y values actually start?
1 infinity.
You could leave it like that. If you want to put less than infinity, I suppose you can, but you don't have to, right? It implies that if you just say y value is greater than 0. Cross out that table because in a second, we're going to decide whether it's linear, exponential, absolute value. I guess if you want to add this is an absolute value table. We did not learn about that because it's no longer in our standards. This is an absolute value function, which is like a linear. It's like, okay, Cora, what are we going to see? Okay. And when it increases and decreases, how is it doing that? Like add, subtract, multiply, divide? Okay. It's going to add or subtract. Keep in mind that your table might skip a few numbers, but as long as the slope actually stays the same, it's still going to be linear, right? Okay, exponential, what are we going to see if it's exponential? What are we going to see?
It's going to be multiplying or dividing by the same.
Great. And then quadratic. Okay, I know that you guys know one thing that you should see, probably at least one thing. So can you please discuss what should you notice if it's a quadratic table? So we might see that. It depends on what type of the part of the table it shows us, right? So sometimes it might show us that, and that would be pretty gracious, but other times it's not going to. So it's symmetrical. Good. That's pretty much it. I'm going to add one more thing. Here's like a trick that you can do is if you it'll have a constant rate of change after finding the change twice. You'll see what I mean in a second. That's like the quickest way to find out if it's quadratic is to take the rate of change twice and see if it turns out to be constant, then it's quadratic. And look at it. Looks like the x's go up by 3. Y's do something. Can you please tell the person next to you what's it going to be?
Up by 3, while the y goes down by 4 every time.
Great. So if we want to write the equation for that, so we already know our slope, right? Our slope is, what is my slope, Owen? Over 3. Negative 4/3 is my slope. Change in y or change in x. And then we plug in to get our b value, right? So I could plug in any 2 points, doesn't matter. I will choose these. 9 is equal to the slope times x plus b. So 9 plus, am I right? 59/3 is b, so my equation is y is equal to negative 4/3 x plus 59/3. So exponential because it's doing what?
It's not going back up in the other direction.
Okay.
And it's dividing itself at a constant ratio of 1/2.
Right. So it's multiplying by half over and over. So that is my common ratio. I need my starting point. You can go backwards in the table. 2, 1, 0. Michael, what'd you say you got for the starting point?
320.
Right, so 160, 320. So 320 times 1/2 to the x. That's your equation for the exponential. I never need you to know this, but it's just fun, right? You'll learn more about it in Algebra 2. This is an absolute value function. Okay? Can you please look at it? It's going up by 1s in the x. What do you notice is happening in the y's?
Symmetrical.
It's symmetrical. Okay, so
I wonder.
here's the thing. You think that it's quadratic, and you might be right, but it might be an absolute value function, right? We just saw this. These are also symmetrical. So you need to double check. Here's what I mean by checking the change twice. You've never done this before, so please pay attention. Some of us aren't paying attention, so you're going to miss it. It changes like this. So it's going, our x's are constant, so I'm not going to bother with that. This goes -3, -1, +1, +3, right? Okay, now I'm going to find the change of those numbers. If it becomes a constant rate of change with the numbers I just found, then it's quadratic. From -3 to -1? From -1 to +1? From 1 to 3? It's quadratic. So that's what I mean by take the rate of change twice. If it comes out to be a constant rate of change, you know it's quadratic. Because it's not always going to show you this symmetry. You might not see symmetry at all, but if you check that, then you'll know. And based on my calculator is y equals x squared minus 10x plus 25.